Good afternoon, everybody. My name's Paul Roberts. I'm from Kiliva Networks. Thank you for joining me today to take part in our webinar, which is all about IP address management. And I've got a colleague with me today, a chap called Keir Pryor-Williams. So Keir's a technical specialist in this area, and Kiliva Networks has got something in the region of about 30 years experience amongst our engineers with deploying IP address management solutions in this space. So what we're going to talk about today is using an IPAM system to replace your spreadsheets. So spreadsheets have typically been used by many people to document IP address allocations. And it's not just IP addresses, it's things like subnets as well, and VLANs. All these things need to be tracked, make sure that they're unique and that there's no duplication. And spreadsheets are fine in small environments. Of course, the great thing about spreadsheets is they're free, but over time they get quite unwieldy. They get larger and larger. You end up with multiple tabs to document different parts of the network, or even multiple worksheets. And then you start getting issues where only one person can have a spreadsheet open at a time. So the second person that opens it gets a read-only copy, and then if they make any changes, they have to save that somewhere, either locally or to the network share. And then you end up with inconsistent copies. One of the other problems is there's no actual integration with the network, so they only provide a static view of what's going on your environment. And obviously there's no integration with things like DNS and Dhcp. So not only do you have to use the spreadsheet to document the allocation, you also then have to go to your DNS services and your Dhcp services to configure host names and leases and like Dhcp pools and things. So you end up with like inconsistencies creeping in and everything getting out of step. So the idea of using an IPAM system is to remove these spreadsheets, put all the data into a central location where everybody can access it, and then you get things like administrative control over the data and a full audit trail and a single unified place where everyone can view the same information. So we're here today to talk about a product from Infoblox. Now Infoblox have been doing IPAM systems for a number of years now. I think it was 1999 I think they were founded. And the product we're going to show you today concentrates on sort of four main areas. So there's the allocation of networks and subnets, and that allows you to also resize and split networks, and you can also create a hierarchy. So you can use this to map onto your network environment and get it to reflect the subnets that you've actually got allocated out there. The next part that we cover is administration, so that's using the networks and subnets that you've created to manage your IP addresses. We've also got reporting, so reporting obviously gives you a lot of insight into what's going on the network. So you've got things like auditing going on, tracking what the changes that are being made, as well as kind of trend analysis of what's been happening over time, how busy subnets are getting, and also how busy your DNS and Dhcp services might be. And the final part of the jigsaw is tracking. So this is using a feature in the product to actually integrate with the network and dynamically update the IPAM database with a real-time view of what's actually going on the network. So traditionally what you might do is assign an IP address to the IPAM system and then provision that on a server. But with this tracking component you can actually do it the other way around. So you could effectively allocate the IP address on the server, and then it will automatically feed back into the IPAM database. It's kind of like doing it backwards. And it's also useful for discovering devices that people have put on the network without provisioning in the IPAM database. So it gives you that sort of holistic view of the environment. So when you log into the Infoblox GUI, you get a very nice dashboard which gives you a snapshot of what's going on in the environment. Things like Dhcp range utilization and subnets over certain thresholds, and these are all customizable, so everyone can have a different view of the dashboard. When we're actually looking at things like networks and subnets, one of the great things that Infoblox have done is they've produced this map, so you can actually see the gaps in between allocations. So you can create your networks and subnets. And the idea is that you can place them in the most appropriate area within your IP address scheme. And that's where a lot of other products typically fall down, because they don't show you the space between individual subnets, and it can be quite difficult to locate sort of free space. So let's say you want to allocate a new /26 subnet. You need to make sure that that's located in an appropriate place within the address plan. So you can also get a list view as well. This is something that Kia is going to go through later on when we do a product demo later on. And we've got a similar thing for IPv6 as well. So obviously with IPv4 running out of address space on the internet, IPv6 is becoming more important for connectivity to the internet. And that might be things like, as well as your external services, things like third-party DMZs, because it's simply going to be, it's going to become increasingly difficult to get IPv4 address space. Now most organizations are carry on using IPv4 internally. They use the RFC 1918 address space, like the 10 network. So IPv6 probably may not be used internally too much, but as we move forward, I think we're going to see more and more requests for IPv6, and the product does that out of the box. Again, using the map feature that we just talked about. When we come on to actual individual IP addresses, Infoblox have got, again, a sort of a map view of individual subnets. So it gives you a quick breakdown of the individual IP addresses within a subnet, and it color codes them so you can see the sort of address that it is. So you can see, fixed addresses, DNS objects, active leases, DHCP ranges, and things like the yellow ones are actually discovered devices. So these are devices that Infoblox has discovered on the network that weren't previously added into the database. So straight away you can start seeing discrepancies in what you thought was on the network and what is actually on the network. And that is obviously something that's very difficult to do with a static spreadsheet. For discovered devices, you can actually see there's a discovered section which lists some of the discovered information, such as the VLAN number, VLAN name, even the attached device name is the name of the switch that the device is connected to, and also things like the port. So from a single view, you can get an idea of exactly where a device is located on the network. Now there's a few different discovery elements within the product. So we just talked about discovering switches, so that's something that we'll talk about in a minute. But the product can also discover just things like devices by doing ping sweeps and also port scans to fingerprint those devices. And it can also integrate with VMware and some of the other virtualization platforms. So for instance, it can discover all the guest virtual machines that have been configured in your VMware environment and pull that information back into the IPAM system. So you can document not only physical assets but virtual assets as well. Now just touching on some of the features in Infoblox, one of the things we've got are these things called extensible attributes. Now these are basically custom fields that allow you to store any kind of metadata against a subnet address or a device address, or sort of anything you want really, kind of like custom fields. So you can configure things like a country and a building code, or you could use a project identifier, and you can group these all together by using filters. So the filters are kind of dynamic. So if you add in a new subnet in a particular building, it will automatically appear within that building folder in the hierarchy. You can see in the bottom right hand corner there's like a little tree view. So this is a great feature for grouping parts of your IP address scheme. And it can do things like show you all the new devices that have been discovered. So it can group them all together, and you can go through and start checking out what these new devices are that the system's found. So it's a really powerful feature. It helps automate the view of your network. So the way this all works, Infoblox basically use a thing called a grid. This is their patented technology. And the grid contains an authoritative database. So this is where all the IPAM data is stored. Now what you do is you insert appliances into the grid, and then the data is shared automatically between the appliances. So typically what you would have is a central grid master. So we've got one here called an HQ grid master. You'll see this one, in this example, is actually two appliances. So we've got high availability there. If one of those nodes fails, the second one will take over. So the gridmaster is the central seat of administration. That's where people log in to do their administrative changes. And portions of that database get distributed out to other appliances that may be in branch offices or remote networks. So that may be, for instance, if a branch office has some DNS data down there, for a few DNS zones, then they'll just have the portion of the grid database that's needed to service those zones. There's different sizes of appliances, so you can have like really small appliances down in remote offices or at the edge of the network, and then as you get further into the core of the network, you might want to have bigger appliances which have more capacity, more performance, including like proper data center appliances. So in order to give you some resilience, there is a gridmaster candidate that you can locate at a secondary site. So that might be your backup data center. And what happens is the gridmaster will automatically replicate a copy of the database to the gridmaster candidate at the backup site. So you've always got like full resilience. If the gridmaster fails, you can just promote the gridmaster candidate and you've got a full copy of the database there. So it's all done automatically. You don't need to worry about configuring a SAN or anything to take care of all this. Now it's not a complete rip and replace solution. We can integrate with Microsoft DNS DHCP services as well. Using agentless technology, we can communicate with those servers. We can manage them, update them, and also do bidirectional synchronization. So if users want to carry on using the Microsoft Management Console to manage those services, then they can continue to do so. We're not forcing anyone to change anything. And the fact that it's agentless means there's no software to install, basically. We've also got integration with various cloud and virtualization services. So there's about half a dozen cloud orchestration platforms that we work with. So for instance, you've got HP Operations Orchestrator, there's BMC, there's Cisco, VMware, and also even OpenStack. So this basically allows, for instance, VMware to request an IP address from Infoblox when you're spooling up a new VM, a new guest VM. So it fully automates the allocation of IP addresses. So you no longer have to wait for someone to manually allocate an IP address. You can do it all automatically. And also release it when that guest VM is deleted. And the final part of the jigsaw here is the reporting server. So this is a box that keeps track of what's going on the network, and it builds up a rich history of things like DHCP activity, for instance, DNS activity, and there's all sorts of things that this box can do, including when we touch on to some of the DNS security stuff later. And it allows you to do historical analysis and looking at trend utilization patterns and all sorts of things. Now all of this system is managed as a single grid, a single GUI. It can all be upgraded as well from the gridmaster. So upgrades are really, really simple. You just upload to the gridmaster and then distribute out to the appliances. Now it's touched on Windows integration. Now Microsoft did bring out their version of IPAM in Windows Server 2012, but it really does lack many enterprise-grade features, and it's fine for like small environments. But when you're looking at corporates and enterprises, there's three different GUIs, for instance. You've got the IPAM GUI that they brought out in Windows Server 2012. There's the MMC snap-ins for managing the DNS and DHCP services, and there's also PowerShell. So there's some command line commands that you have to run to configure certain aspects of DNS and DHCP. So there's no real sort of single central place to do the management, and there's no IPAM automation. So there's no integration with VMware or even Hyper-V, for instance. The discovery is only limited to servers attached to Active Directory. There's no global search. You have to log into the individual GUI, so you have to go into the DNS manager to search DNS records. And there's no reporting either, so it really does lack many of the enterprise-grade features that people require and in fact demand these days. And there's just an example, for instance, of the mixture of GUIs that you get when you're using Windows Server 2012 IPAM. Something else we just wanted to mention is there's a great feature in Infoblocks which is unique to Infoblocks, and that's this Dhcp fingerprinting capability. And what we can do is detect the type of device that it is just simply through its Dhcp fingerprint. So this is kind of like the options that it requests and the order of those options in the Dhcp request packet. So based on that, we've got all these signatures, and we can detect the type of device that's trying to access the network. That means then we can set policies based on these device types to say, you can, for instance, block or deny all Android devices that are trying to access the network. And this all gets sent into the reporting server as well, so you can see trends over time of how many devices are coming onto the network and what sort of type of devices are they. So it's a really useful feature, especially if you're running like a BYOD environment. So moving on slightly to another area, Infoblocks have got this module called Network Insight, and this is the bit where it interrogates the network and gives you real-time infrastructure information by querying the switches on your network. So the idea is you gather the data from the switches, you can then analyze that data. So that might be, for instance, looking at port utilization. So show me a list of ports on a switch and which ones are actually active, which ones are inactive, and how long have they been inactive. If they've been inactive for 3 months, there's a fair bet that that port can be reclaimed. So you start getting your cost savings here. Instead of going out and buying more switches, you can start reclaiming old ports. And this information is all presented in the single GUI as well. Obviously you can then take action as well based on that information. You might have even detected something like a rogue DHCP server on the network, or a strange VLAN that you don't recognize. So it allows you to go and investigate what's going on and remediate those devices. So when we're looking at Network Insight, we basically get a device tab in the GUI, and we can start seeing things. If you look at the column headings here, you can see things like the vendor, the model, and even the version. So you've got, looking at some of the Cisco devices, you can see the iOS version, and it pulls a description back as well. So it's a great way of just looking at the inventory of your network. But you can actually query each of these devices and get a list of ports, see what devices are attached to them. The system can also discover unmanaged networks or subnets. So these might be subnets that have been configured on a switch or a router that hasn't actually been added into the IPAM system. And what happens is they come up in yellow in this particular GUI, and you can basically click on it and then do show device. You can get a list of infrastructure devices on that subnet, and then you can go onto those devices and get a list of ports. So what it's allowing you to do is marry your kind of theoretical view of your network with what's actually happening, the realistic view. And some of the use cases, things like locating a MAC address or an IP address. Let's say you have a virus outbreak or malware or something that's been reported by your firewall. You can trace that MAC address or that IP address by searching in the system, and then it will show you which switch and which port that device is connected to. You can go to that switch and then just turn that port off and isolate the device. We can also detect things like rogue devices. So this might, for instance, in this case, we've got a Linksys router that someone's brought in, plugged into the network. And because we're doing a port scan on that device, we can tell it's running DHCP. So we can flag that up. We can pop it into the smart folder, like I mentioned earlier, as an unauthorized DHCP server, and then you can go and remediate that device. And also things like suspicious VLANs. So if a VLAN pops up on the network you don't recognize, again, we'll detect that. We can pop it into a smart folder. You can go off and investigate. And another use case, as I mentioned earlier, is just about capacity planning. So just seeing what open ports you've got on the network. Now, as we move forward, we started off just talking about IPAM, but we start getting into kind of a DNS security area here as well. DNS is being used a hell of a lot at the moment by malware. There's lots of exploits using DNS. And things like botnets, for instance, and the malware will try and communicate with a botnet by looking up the DNS name. So DNS normally traverses in and out of networks quite easily without too much checking, just simply because it's required so much. So if you've got a piece of malware that's looking up the command and control server on a botnet, what we can do is we can look at the name that's being looked up and block it if it's a known malicious botnet. And this is Infoblox's approach. They call it a DNS firewall, but it's really a filter that just filters DNS names. And you can create your own blacklists. You could block Facebook if you wanted to. But also Infoblox provide a data feed, which is really where the power of this comes in. So the data feed will actually provide a list of malicious DNS domains to the Infoblox DNS firewall, and that gets updated regularly throughout the day. And then the DNS firewall automatically downloads a fresh version of that data and distributes it to other firewalls within the grid automatically. So if somebody's trying to actually visit a bad site, this might be either in the data feed, or it might be something you've configured, for instance facebook.com, and we can apply a policy and redirect that user to a landing page or a walled garden, just maybe telling them they're not allowed to visit that site, or redirecting them to somewhere safe. Likewise, if you've got malware on a client, so you've got an infected client and it's trying to talk to a botnet, then again we can just block that and drop that session at the DNS level, so that infected client can't actually communicate with the botnet, can't receive any further instructions, and can't do any more damage. Furthermore, these events get sent out to the reporting server, so you start building up a picture of all the malicious events that are happening on the network. So that's talking about threats that are inside your network that are trying to get out. There's also the opposite is happening, where you've got inbound threats targeting the DNS infrastructure. So you've got people that are attacking your DNS infrastructure, or people that are using your DNS infrastructure to attack other people's infrastructures by doing things like amplification attacks. And this threat is significant. It's growing really, really fast. You can see just over the last year they've gone up over 200%. And there's other protocols being attacked as well, but DNS is currently like the #2 attack vector. But the way things are going, it's probably it could quite easily overtake HTTP the way things are going. And the trouble is, using DNS, it's so easy to generate huge volumes of traffic. I did a little YouTube video on DNS amplification attacks just to explain what they are. So you could visit our YouTube channel to get an idea of what that's all about. So what Infoblox have produced is an advanced DNS protection. What this is an appliance with a little bit of extra hardware in it, so that it can handle massive amounts of inbound DNS traffic. And what it's doing is it's looking at the DNS packets and checking that they're valid and they're not malicious, or that it's not like using an exploit, or not doing any tunneling, or not doing any DDoS attacks. And what it can do is it can drop that traffic, if it's malicious, before it actually hits the DNS service itself. So it's kind of like an additional layer of protection. We've got centralized visibility as well, because all that information is being reported back to the reporting server. And we've got ongoing protection, because these threats are getting updated via a rule set automatically, a bit like the DNS firewall feed. So that means that when there's a new threat comes out, you don't have to wait for the DNS code to be updated. You don't have to go and patch everything. You just simply, you will automatically get the update from the threat rule set. So before you know it, you're already protected without actually having to go and patch all your DNS servers. And it works in conjunction with the grid. So you can drop in some advanced DNS protection appliances to protect either your external authoritative DNS or your internal DNS. And then all the attacks that are coming in will get blocked, and then data gets reported out to the reporting server, so you can see what's going on, give you visibility. And we've got the automatic updates and grid-wide distribution as well, a bit like the DNS firewall. And again, it's all managed through the grid, through a single GUI. So just to summarize, we started off talking about IPAM, but as you can see, it gets a little bit more than just replacing spreadsheets. we can start off with your spreadsheet replacement and then integrate with DNS and DHCP to give you like a single golden source of IPAM information. We can also integrate with Microsoft, so you don't have to do rip and replace. You can just integrate with what you've currently got, and we'll automatically do bidirectional synchronization. We talked about network insight as well, so that's bringing in what the reality of what's on the network into your environment. So it's giving you kind of a more dynamic IPAM database. We also mentioned about DNS firewall, so that's blocking the outbound traffic going to command and control servers and botnets. And we've also talked about advanced DNS protection, so that's protecting you effectively from inbound threats. So as you can see, it's quite a wide-ranging topic, and we've seen a few screenshots where there's a number of boxes on the screens. But the thing is, you can just start off with a single box running IPAM, and you can even run it in VMware as well. That's something I might not have mentioned, is that you don't have to roll out appliances everywhere. You can do it all in VMware, and then grow the solution to fit your needs. So next steps, please get in touch if you've got a requirement. We can do on-site demos and evals, and normally there's an approach that you need to take to a deployment. There's normally kind of a migration process that you would have to follow. We obviously need to do this so that we don't disrupt anything that's actually happening in your real live environment. And like I mentioned earlier, Cleaver Networks has got about 30 years experience of doing these kinds of deployments. So feel free to reach out to me directly. My email address and phone number are on the screen there. What I'll do now is I'll hand over to my colleague Keir, who's waiting patiently in the background, and Keir will give you a quick overview of this solution.
Thank you, Paul.
Okay, so I'm just making Keir the presenter.
Okay, so hopefully, thumbs up, you should be able to see the GUI in front of you. So it is fully browser-based, so there's no additional requirements for any local clients or Java installation or software on your local PC. As long as you have a browser, you're good to go. So the first thing I need to do is need to authenticate with the platform. So here I'm using a local account, but alternatively you could call out to an existing authentication platform that you already have in your environment, something like AD or Radius, in order to give you that kind of simple sign-on and password management. So when we arrive at that tool, I just want to take a moment just to recap on what we're really looking for in an IP address management system and the benefits of also integrating it with DNS and DHCP. So what we want is a comprehensive visibility of a company's IP address space. So we don't want siloed data, different spreadsheets owned by different people, different teams. We want to go to one place and get full visibility of our IP address space. Centralized management of DNS and DHCP services, again, get away from managing boxes on a server-by-server basis. Simplified IPAM, DNS and DHCP changes, so we're reducing administration tasks. So I'm going into one place and I'm performing one task. When I'm performing an IP allocation, I also want the ability at that point to do the DNS and DHCP registrations if necessary as well, rather than having to go to multiple GUIs, multiple windows, and repeat the task over and over. Delegated and role-based administration privileges, so that way I can now start to delegate certain tasks down to certain individuals or teams, allocate a portion of the network and let one team own that and concentrate on managing that bit, while maybe giving them visibility of the rest, but not them being able to make changes on the whole of the data, but just their portion of the data they have access to. Enhanced audit trails of changes performed by admins, so I can see who deleted what or changed or added something, where and when. So to summarize, we're really looking for a single GUI, a single pane of glass that for management, monitoring and auditing of IPAM, DNS and DHCP services. So here it is. Once we're into the product and we've logged in, we arrive at our dashboard, and here we have two tasks. We have the main status dashboard, and this is really just giving us an overview of what's going on within the product. It is really a status update of the actual platform or of networks, statistics, so DHCP, DNS statistics, network IPAM statistics, and also shortcuts if I want to quickly just get in and add something quickly, add a network, allocate a new IP address, I can do it very quickly from the dashboard. All of these dashboards are fully customizable. I can add new content to it, so tailor the dashboard to what I need to see to perform my role within the product, and drag and drop all of these around. So get this into the look and feel and how I want my dashboard to look. The other panel we've got in the dashboard area is tasks. So again, this is just giving us a very quick entry into performing a simple administration task, such as adding a new network, creating a new IP allocation or DNS records. So the main day-to-day task we'll use is the data management tab, and within here again we have our main sub-tabs, IPAM, Dhcp, DNS, the primary ones. But the key one really is IPAM. This is the main one we'll use in a business as usual type when we're looking at allocations, creating new network definitions, etc. So here we can see here our traditional overview of the data, like a typical spreadsheet view. We've got different columns here showing different values. Here we can see IPAM utilization. So this is what we're looking at, something called a network container. So effectively this is creating a hierarchy of IPAM and the IPAM network. So the container is actually like summarizing a bunch of networks underneath it, for instance 10/8. So the utilization we're looking for here is actually how many subnets have been created, for instance with this /16. So I can see how many more additional networks I can create within this parent container. As we move along, we also start to see some data around it, and also things at the end here are extensible attributes that were alluded to in the presentation earlier. So this is additional custom-defined metadata that you can also assign to the data within it. So in this case, it's networks, and this could be anything that really fits your requirements. So it might be regions, countries, cities, data center, office floor space where that network resides. It might be VLAN IDs. It might be the network usage. So is it a data network, a voice network, server network, printer network, etc. Really, whatever type of information you want to record against a network, you can use extensible attributes here. And these columns are fully customizable. So again, I can drag them around and get them to fit and get the right look and feel that I want. But with that data as well, I can also use filters to filter that data out. So I can apply a filter, I can then save it and use it as a quick filter. So in this case, we've got one called IP version here to segregate out IPv4 and IPv6 allocations. So I can quickly apply a quick filter, and then I'm just restricting the view that I've got just to the IP allocations for IPv4. Take the filter off. Okay, so when we start looking down at end subnets and creating new ones, here again we'll drill down into our parent container, and now we start to see end networks as well. I've got here my containers as well, so this is still creating that hierarchy of networks, so I can still continue to drill down in between containers until I get to the end networks. So here we can see that we have this breadcrumb trail effect, that I've gone from the main home page through my /16, drill down into my /24, and I'm now seeing the underlying end subnets or end networks within this /24, which is a couple of /30s for point-to-point links. Click on the link to jump back up to one of the parent containers. And now when we look at it, again, same view to what we saw before. The only slight difference here is we've still got IPAM utilization, but when we're looking at it in terms of an end subnet, so when I click into that end subnet, I actually start looking at individual IP addresses. The IPAM utilization changes to actually the allocation within that subnet, and how many IP addresses have been allocated or are in use. So for instance, in this /24, I can see that roughly 50% of my IP addresses have been allocated. I've still got another 50% odd to be able to allocate out to new hosts. So that is our traditional like spreadsheet view almost, but what we have got is our net map, which is our graphical overview of the address space. So it's still looking at the same data, but it's just looking at it in a graphical view. And this simplifies, looking at basically where the gaps are. So I can hover over white space, and I can see now what size networks in there. The number of /24 networks I can fit into there. Again, different colors to represent different things, whether it's a container or whether it's a leaf network, essentially an end subnet, and also a watermark feature as well. So this is the kind of dots there are linked back to the utilization. So that's just representing the utilization of that particular network. So from here, if I wanted to allocate a new network and I wanted it to be within this particular area, I could click the plus sign, the wizard comes up, and I can drag that and say, okay, well actually I just want to create a new /24. My new block appears here, so I can hover over it and it will tell me the address. If I want something slightly different, I can just drag it to a new position, and then once I'm happy with where that's going to be allocated, I can launch the wizard into allocating a new network. So when we start to allocate a new network, we have a few options. The basic one is, so I'm going to add a new network. I click Next. So here it's a /24. It's already pre-populated the network address because I chose that particular address within the netmap view. The alternative thing we could do is just to click plus on here. Actually, let me go back to the list view. Add a network, same process before. If I know the address I want to add, in this case I haven't pre-selected an address, but I could just click on the add and start typing in an address space. The alternative is, if I just want the product to basically select the next available address or addresses, I can use the next available network feature. I'm not limited to just creating one network. I could create half a dozen networks. I'm quickly going to go and select where I want to create them under. In this case, it's going to be my /16 container. Add next, and here I get my list of networks that I'm going to add. Okay, so I'm happy with that. So a few other things. Comments, basically I can fill in for each of the networks a particular comment for that network, so just a label on that network. I may choose to automatically create the mapping DNS reverse zones for it, create or disable it within DHCP. Members and servers, we now start getting into a DHCP area. So if I want this to be a DHCP enabled network, I can start to add in the DHCP servers that are going to be looking after this network. So in this case, it might be an Infoblox member, or it might be a Microsoft DHCP if I'm also managing Microsoft DHCP servers within it. Carry on through, and we get extensible attributes within that. So again, this is about assigning the metadata to it. So these attributes, there's basically three states that can be there. It can either be mandatory, so the attribute will automatically appear in this window, and I must fill in something as a value for it in order to be able to proceed and save it. It could be optional, i.e. I can add it if I want to and fill in a value, or it could be recommended, so it will appear there. It will prompt me for a value, but I don't actually have to fill the value in order to continue and save that object. So once we click Save and Go, we'll just get our new networks filled in. And then typically what you would then do is then you would start to drill down into that subnet and then start to allocate end IP addresses. So maybe to your switches, routers. If it's going to be a DHCP enabled network, I can create a DHCP range. But again, in order to be able to shortcut the admin processes, what you can do is you can predefine network templates, so your networks get the same look and feel as you want them to exist, because typically if you get 5 different people to create a network and then define things like DHCP ranges, etc. inside it, you'll probably get 5 different ways that they've been configured. So in order to standardize that and get a consistent look and feel, we can use templates. So same process, add a network, but this time I'm going to add a network using a template. Select a template, so you could have a bunch of templates depending on what your requirements were, whether you were adding /20s, /24s, whether they were DHCP enabled or not. In this case, I've just got a DHCP template when I'm creating a /24. So go through the same wizard. The net mask is already grayed out because that's been predefined within the template. So I'm going to use the manual address. I can just quickly look in here. Let's go for 15.0. Give it a comment to label it, extensive attributes, and then I can hit save and close. And here I can see my template network /15. So that's added my network the same way. What I can now do though is drill down with that network and see the end IP address allocations. So here we can now start to see actually the IP addresses have already been allocated out, so I don't have to come in to the subnet once I've created it and start predefining standard things that I would typically expect to be defined in my networks already. So this is the list view of a leaf subnet or a terminal subnet and end subnet. So this is where I actually start allocating out IP addresses to hosts. So same thing, we've got our kind of standard list view of all our IP addresses. You'll start to see kind of host names, MAC addresses, status, so whether they're used or unused. I can then start to allocate out unused IP addresses and what the usage is, so it's a DHCP range. And here, lease state, whether a client has currently got that lease, whether it's active, whether it's not. Some of the other columns here are also linked into other parts of the product, so such as some of the discovery mechanisms. I can start to see the discovery processes will pick up things like NetBIOS names, what ports have been identified, DHCP fingerprinting, which we looked at earlier on the presentation. And again, I can start to create the look and feel how I want it to within this, so I can add in columns that are relevant to what I want to see in it, and then I can change those about and drag those over to where I want that to appear within the table view. Same filtering going on here, so again, if I just want to see my DHCP objects, I can apply a filter just to see DHCP enabled stuff, or if I just want to see the used or conversely the unused allocations within there, I can use filters to view that data. Similar to the network view, we also have two ways of viewing the data. We have our list view, which we're looking at here. We also have our IP map view, again, which is a graphical representation of the space, and it quickly gives us a snapshot of what's used on the network and how those objects are configured. So again, DHCP range is this shaded area here, objects here that have been reserved for future use, so I can now start to go and allocate those to my switches, etc. If I blocked out an address range for use for servers only or printers only, I can now start allocating addresses out of those to printers or servers. And hover over areas, and I can start to get more information down below, either from information that's been entered when I've been allocating an IP address, or information that's been discovered about the object. Okay, so what we'll now look at now is allocating standard IP addresses. And once I've got my network defined, typically my next job will be to start handing out IP addresses. So a few ways to do this. I'll go to my subnet and someone will say, right, I need a new IP address, and okay, well, .10, I'm happy with that, that's free, so I'm going to add a new host address, which is the typical way of adding an IP address out. Here I can start to give it a name. Already got a predefined domain because that's associated with this particular zone, enabled in DNS, so this host is going to go directly into DNS once I click Save and Close. IP address, as I pre-selected an IP address, it will appear here. If I want it to be enabled in DHCP as a DHCP reservation, a fixed address that's going to be handed out via DHCP but linking the IP address to the MAC address, I can enter the MAC address here and then tick the box to link it to DHCP. So that will automatically provision the DHCP side of it as well. Likewise, I can, if I've got multiple IP addresses associated with this particular name, I can add additional IP addresses in here. I can use the next available IP address function just to automatically predefine the next available IP address within the subnet that I've selected. IP address IPv6 if I'm using IPv6. Comment, again, if I want to label this in any particular way. Again, next, extensive attributes. I can define attributes here. So now I'm starting to use a kind of global name to link together different hosts, but to a same common node value. Once I'm happy to that, I click Save and Close. So in the product now, that will allocate out to the IP address. So I'm now marked that IP address as used. I can see the name of it in there, MAC address. I can see that its usage is both DNS and DHCP, and I've got my node allocation there. So what hopefully that has done is just with one click by allocating the IP address out, it should have also updated DNS as well. So that should now be resolvable in DNS. So if I go and send a query to the DNS server, I can now see that actually that host is in there, and because I added it with two IP addresses, I now get the 2A's records back. It's also will have done the reverse mappings as well. If I can type properly. And there we go, we get the reverse resolution. So I haven't had to do any additional steps from the DNS front as well. I haven't had to go to any DNS tab or separate DNS console to configure DNS. So commonly there's a few ways that we want to look at linking objects together, because nowadays more and more hosts have got multiple IP addresses or multiple interfaces associated with them. So again, if I want to, rather than having all of the IP addresses associated with just one common host name, I may have a requirement to provide unique names for individual interfaces, but within a particular server or service, but still have those linked together. So for instance, if I've got a main interface, but a management interface as well, I might have an extension of -mgt on the client. So what I can do, I can add multiple host records with unique host names, but just give them a common a node value with the extent attribute in order to be able to group those together. So we'll call this gold MGT, click next, and I'm just going to assign the same node type there. So I expect I could do a filter and use something like filters to restrict the data that's shown to me and only show items that match, or likewise I could use actually the global search at the top. So if I click on the magnifying glass top right, and again just type that in, hopefully I can start to see anything with a gold node value. So I go there from here, I can then group all those objects together. And again, if I'm decommissioning, it becomes quite a simple task to actually then remove all of those IP addresses from IPAM by using the global search. Okay, so sometimes what you want to do when you're allocating IP addresses, you might be restricted into chained windows. So rather than just being able to allocate them when you want throughout the day, or creating new network definitions or DHCP ranges, DNS objects, what you might want to do is actually schedule those to occur at a certain time, and that's impossible. So pretty much anything you can add when you get the wizard up, you go through exactly the same process. But we've got a calendar icon on the top. Schedule it now, that's the default one. As soon as I click Save and Close, it's going to be defined in IP allocation in IPAM. It's going to create a DNS entry for it. It might create a DHCP entry for it as well if I required that. But I can schedule it to happen later as well. So if my change window starts at 7 o'clock, I can configure all the changes that I want to make up front, but they won't actually become active and propagate into the system and propagate throughout DNS and DHCP until that time that's been configured on them. So I can go over to here. They've changed this around. So here we can see that's my schedule 1. That's going to be completed here. So current status is pending, when it's going to be completed, what time, etc. And that actually, so that workflow process, as it's labelled here, also actually extends through to using a more fully blown workflow process, where actually I can empower users to use the workflow so they can go and add stuff into it but they'll be forced down a workflow process whereby they can go and queue up all their changes, but it will need an approver to actually go through, look at all the approvals that are currently outstanding, and only when that approver actually accepts those in the workflow processes will they become active on the network. So if you have an approval workflow, the product can use that to kind of automate that approval workflow and get you guys to submit their changes and get the approver to go and actually activate those changes within the product. Okay, so really the final bit I want to touch on the IP allocation bit is to do with bulk changes. So typically, a lot of people are now adding, they're not just doing one IP allocation at a time, they're doing a number of allocations, what we can probably refer to as bulk adds. So rather than sitting here and maybe having to add 10, 20 individual hosts, there are ways that you can shortcut that process out. So from the dashboard on the task menu, we've got the add host task. And here we can just add column after column of objects here, so names and IP addresses, etc. So I can use that to define a bunch of hosts in one go, click Save, and that will add them all in. Kind of progressing on from that, we have a CSV Import Wizard. So you can predefine a CSV file, build out a template of that, and then you can go and define all of your allocations in there, so IP addresses, host names, domain names, whether they're DHCP enabled or not, any extensive attributes, and I can use that import manager to automatically upload those bulk changes within the CSV into it. But it also extends on to becoming more intelligent, more automated. It's got quite an extensible API, so you can create your own custom applications which interface within the product and use that to create objects how you want. So that might be that I want to go to, when I'm creating a new host allocation with multiple interfaces associated with it, I just go in there, predefine the common host name, select multiple networks where I want an interface to appear, use the next available IP functionality within the product to automatically allocate those IP addresses, and then because I know that this particular network that I'm allocating an IP address from is a management network, I can use it to automatically append a -mgt prefix or postfix to the host name. When I'm doing that, click Go, and it will automatically build out those allocations in the product. So the API is very powerful for you to create custom applications however you need to manage your IP address allocations. Okay, just want to jump back onto looking at the finder bar on the left. First, we're just going to focus on smart folders. So this is basically looking at the IPAM way. There's a very hierarchical, it's grouping it, being dictated really by our IP addressing plan. So for instance, when I go down to here, 20/8, I'll see all the networks under the 20/8 network. But there might be a requirement for you to group those networks together into a more logical way. So for instance, you might want to see it by data center, and then in that data center you have non-contiguous address spaces. But whereas the IPAM is very hierarchical, the smart folders can be used to group those subnets together in a non-contiguous or logical manner. And we're doing that via the extensible attributes. So when we're adding something new, we're labeling up extensible attributes. If I draw down into here, I can see that I've started to got my region of EMEA, my country of France, my site is Paris, etc. And what that does, it creates a network hierarchy smart folder where I can then start to see those attributes come into play. So I can drill down through EMEA, through FR, Paris data center, and I can see the subnets that are related to that Paris data center. Likewise within the UK, I can see subnets that have popped into there. So here we've got a mixture of IPv4 and IPv6 ones that are associated with this. And these are dynamic, so as soon as I add a new network, give it the relevant attributes, it will automatically plop in to the relevant hierarchy within our smart folders. So again, very powerful way of representing the data that you want to see, but maybe in the way you want to see it. Carry on down, just a few other shortcuts. Bookmarks, so again, nothing really different to internet bookmarks. It just is a way of giving us a shortcut into an area. So as soon as I've logged into the product, if I want to quickly jump to a particular DNS zone or a particular network, I can use the bookmarks to take me there automatically without having to navigate down through the hierarchy. Recycle bin, quite an important one. If I delete something, millisecond after I've clicked the delete and confirm button, I've decided that was quite bad, I can go into here and then I can use the recycle bin to actually go and restore that data. So again, it's a kind of get out of jail free card that hopefully I can quickly restore something that I shouldn't have deleted in the first place. So that really brings me to the end of the IPAM piece. I just wanted to briefly touch on the DHCP and DNS. So again, most of my allocations are done from IPAM when I'm doing day-to-day stuff, but DHCP gives me a more relevant view into DHCP. Again, utilization here, I'm actually looking at DHCP allocations within a particular subnet. So where I might have a range of, in this one, let's say, 20 DHCP hosts, I can quickly see into here how many of those IP addresses have actually currently allocated out to DHCP clients. And I can alert on that as well. So if I'm approaching a kind of 90% usage on a particular DHCP range, I can send alerts out. So I can either take some sort of remediation work before I've exhausted all my IP addresses. The DNS is, again, looking at the data, but from a DNS perspective. So here I can see my list of DNS zones, and I can drill down inside those zones and see the allocations in here from a DNS perspective. But again, anything that I change in IPAM and Allocating DNS would automatically appear in here. Likewise, if I make any changes in here, allocate a new host record within the DNS view, give an IP address, I will go back to IPAM, and I can automatically see that that information has been updated in IPAM. I don't have to do it in two different places. So that really brings me to the end of the demo of the product and this for the overview product. I don't know if there's any questions, Paul, online, if anything specific we need to look at.
No, that's fine, thanks, Keir. So let me just see if I can get control back. Make a presenter. Right, okay, so yes, there we go. So so that's the end then basically of the webinar. So as I just wanted to reiterate, it's all about saving time at the end of the day, making things smoother and eliminating errors. So obviously we can eliminate errors because you're only actually doing the provisioning in one place now, and then it's automatically updating DNS and DHCP. So you're eliminating some additional steps that traditionally you would have to take care of. And yes, and obviously we're saving time because we're reducing the amount of effort involved in doing this. So we can do demos on request. We can come on site, set the software up, and leave it with you for an eval for a period of time. There's loads of different ways of actually looking at this this solution. So feel free to get in touch, and hopefully we'll speak to you again soon. So that's the end of this webinar. Thanks very much for attending.